Hi, third grade. I just sent a video and it was too long, so I'm going to have to hurry through while I read this selection, um, Life on the Ice. So I want you to have your Journeys books out, and we're going to start on page 169. I am going to cover the screen because if we were in Antarctica, we might be in what's called a whiteout. And in the book, you'll hear them talk about how sometimes it feels like they're inside a ping pong ball. Now, a ping pong ball is white all around, so imagine white above you, below you, in front of you, behind you. Here we go, page 169. The essential question is, what are the coldest places on Earth like? So that's what we want to listen to find out. Open to page 170, where we see the picture, and the North Pole is located in the middle of the Arctic Ocean and is usually covered by ice. At the top of the page, the top and the bottom of our planet are covered with ice. The top, the Arctic, is home to the North Pole. It can be so cold that a cup of hot water thrown in the air will explode into a cloud of ice particles. Page 171. There we see a big iceberg, and it says the ice covering Antarctica contains about 70% of the world's fresh water. And they ask us to keep track of some details that help support the main idea that Antarctica is one of the coldest places on Earth. Reading at the top of the page. The South Pole is at the bottom of our planet on the continent of Antarctica. This region is even colder than the Arctic, sometimes plunging to minus 125 degrees Fahrenheit. That's 125 degrees below zero. In winter, parts of the oceans surrounding Antarctica freeze over, doubling its size. Antarctica is the coldest, driest, windiest place on Earth. It is so isolated that no human had even seen this continent until 200 years ago. Page 172. We see icebergs, and they can be as small as a piano or larger than a small country. Places this cold, this extreme, are hard to imagine. In fall, the sun sets and doesn't rise again for the entire winter. Months later, it shines 24 hours a day, all summer long. Even though they are covered by ice, these regions are deserts, dry like the Sahara. Very little snow falls in either place, but when it does, it rarely melts. Over time, the snow becomes ice, in some places almost 3 miles thick. Page 173. This ice is slowly moving, inching from the middle of the Arctic and Antarctic to the coasts. By the time pieces break off into the ocean and become icebergs, the ice is 100,000 years old. So that takes a long time to travel. Page 174. I want you to listen for the literal or non-literal meaning of this when the pilots say that they feel like they're flying inside a ping pong ball. No one's ever flown inside a ping pong ball, but I would imagine if I looked around, everything would just be white, and I wouldn't know up, down, front, behind. Let's read. People fly thousands of miles to reach the poles, and when the winds kick up and blow the snow around, it's hard to know where the sky ends and the land begins. Pilots say that it's like flying inside a ping pong ball. Many of the instruments normally used to guide planes won't work here. In fact, navigators flying to the poles are the only ones left in the United States Air Force who still help map their route with the stars. This is some of the hardest flying there is. Remember we talked about how you can find the North Star and then find direction from there? These pilots use the stars. Page 175. Look at the caption. When pilots land at the South Pole, they keep their engines running. It's so cold that they might not start up again. Let's read at the top. Planes do not land in these wintry worlds by rolling down concrete runways. They use skis instead, and they slide like giant sleds until they stop. Gliding along, the skis get so hot that they melt the snow they're resting on. Pilots must pull them up when the planes stop. Otherwise, the wet snow would refreeze on the skis and the planes would be stuck to the ground. Page 176. It sounds like an adventure story, doesn't it? It is an adventure story, one with science. Scientists are today's explorers, braving the wilderness to learn more about our world. The snow near the North Pole, for example, hasn't melted since the last ice age. Over 100,000 years of it has been pressed into an ice sheet almost 2 miles thick. But each layer looks separate, like the rings of a tree. Page 177. Some scientists use this snow to measure air pollution. Others are drilling through this ice to pull out history. Each sample they bring up tells a story about the time when it was formed. Scientists have found volcanic ash from Italy's Mount Vesuvius, for instance, and pollution from ancient Roman times. Scientists began this experiment to learn more about how ice ages begin and end. Before, they thought our climate needed thousands of years to change. Now they know it can happen much, much faster. Turn to page 178. At the South Pole, some scientists search for meteorites, rocks from outer space. Meteorites are no more likely to fall there than anywhere else on Earth. But as one scientist explains, if you want to find something dark, it's easier to look on a big white sheet. His team has given thousands of meteorites to our space agency, the National Aeronautics and Space Administration, NASA, for study. The next page. The Antarctic sky is a perfect window to the stars, the best on this planet. It is very clear because it's so cold and dry and has a night that is 6 months long. Some scientists use telescopes to study the age of the universe. Others fly balloons to measure rays coming in from outer space. Page 180. Remember the caption? No wearing rings, earrings, or sunglasses with metal frames in the extreme cold. Metal gets so cold that it will freeze any skin that it touches. Let's read at the top. At the poles, people wear many layers of clothing to keep warmth in and wind out. They wear big boots and overalls called fat boy pants. Their mittens have furry backs to wipe their noses and warm their ears. They also wear goggles. Without them, their eyes would get sunburned and temporarily blinded by the strong light bouncing off the snow. Page 181. Let's read the caption. The body is like a furnace that needs fuel to keep running. It works so hard to stay warm at the poles that people end up eating at least twice as much food as usual. But they don't get chunky because they work it off. Let's go ahead and read. People who work at the poles must learn how to survive being stuck outdoors. On an unexpected camping trip, they first build a quick shelter to get out of the wind. Then they build a better one and pack in close to one another using body heat to stay warm. Building shelters, doing any work, is much harder in the extreme cold. Mittens are very bulky, but it's unsafe to go barehanded for long. Getting too cold is dangerous, but so is getting overheated. Sweat can freeze into a layer of ice next to your body. Page 182. Unlike most refrigerators, the one containing fruit and vegetables at the South Pole is heated. That means the freezers that we have here are not as cold as it is in Antarctica. Let's read at the top. In summer, many people live at the science stations in the Arctic and Antarctica. They have a gym and videos and spend their spare time skiing on the icy runways. But mostly they work hard, getting as much done as possible while the weather is warm enough for planes to fly in and out. A few of them stay all winter long. Scientists say that summer's constant daylight tricks your body into wanting to keep going without rest. But in winter's endless darkness, you feel tired much of the time. One scientist even studies the people who winter over at the South Pole. He wants to know what kind of a person works well in such a small, isolated group. Someday his findings may help pick the people to live in a colony on Mars. Page 183. In spring in Antarctica, the temperature finally climbs up to 10 degrees above, and it's warm enough for planes to fly in again. The scientists are eager to get on board and return to the colors and smells of the green world. I think they mean trees and grass and plants. Once they buckle up, there is one last frosty problem to solve. The airplane must go 100 miles per hour to take off. No easy task when sliding over ice. Sometimes pilots must travel 2 miles to reach that speed. And sometimes they need extra help. Then they turn to the 8 rockets attached to their planes. Page 184 and 185. A flick of the switch, a burst of flames and speed, and they are on their way home. Thank you for listening.